to this computer. All right, hi, it's Mrs. Jandro, and this is geometry class, and I'm going to go through lesson 10.4 notes. So you received the note packet in class, or if you didn't, you can just copy some of these notes down in your notebook. So section 10.4 is on perimeter and area of similar figures. So, first of all, what are similar figures? If two polygons are similar, their perimeters are proportional to their scale factor. They're proportional to their scale factor. Okay, and if two polygons are similar, their areas are proportional to the square of their scale factors. Okay, well, let's look at an example. What does that mean? So if we look at this table right here that I have for you, look at this tells us that triangle ABC is similar to triangle DEF. Remember that curly little thing means similar. SIMILAR. They have similar ratio. So what does that mean? It means that AB over DE is 5/10, which reduces to 1/2. AC over DE is 4/8, which reduces to 1/2. And BC over EF is 3/6, which also reduces to 1/2. So their similarity ratio is 1/2. Well, let's look at the ratio of their perimeters. So if I add all of those together, 5 plus 4 plus 3, I get 12. And if I add all these together, 10 plus 8 plus 6, I get 24. If I put 12 over 24 and reduce that, check that out. The ratio of the perimeter is also the same as the ratio of the sides. Okay, well now let's look at the area. So let me switch colors here. The area of this little triangle is 1/2 of 3 times 4, so that's 6. The area of the bigger triangle is 1/2 times 6 times 8, which is, let's see, 6 times 8 is 48, that's 24. So now when we put the area of the little triangle over the bigger triangle and reduce that, we get 1/4 is the ratio of their area, which isn't the same as the other two, but actually 1/4 is 1/2 squared. So the area ratio is their scale factor, or their similarity and perimeter ratio squared. All right, well, let's talk about that in another problem. So first of all, the trapezoids are similar. So that's important. You need to know that they're similar. And then it says the length of, here, I can move my head here. The lengths of corresponding sides is 6 over 9, or 2/3. So you see the picture, and that's 6, and that's the length of that side, and that's 9. And so the ratio of the littler one to the bigger one is 6/9, or reduce it to 2/3. That's the ratio of the sides. What's the ratio of the perimeters? Well, that's the same thing. We just learned that in the last slide. So that's 2/3. What's the ratio of the area? Well, I'm going to start with the reduced one, and I square it. Think about area. Area is always the label squared. If the label is feet and I find the area, it's feet squared. If the label is centimeters and I find the area, it's centimeters squared. So the ratio of the areas makes sense that the scale factor ratio is squared. So my answer would be 2 squared is 4 over 3 squared is 9. That is the ratio of the areas. Ratio of the area. All right, well, see if we get it, we can keep going on it. So the next one says the box, here we go. The area of the smaller pentagon is about 27 centimeters squared. What is the best approximation for the area of the larger pentagon? Okay, so the first thing we need to do is we need to write down what our scale factor is, or our ratio of the sides. That's our scale factor. And our scale, but I did a really poor job of writing scale. Let me try that again. Sorry about that. SCALE. This pen is a little tricky. So our scale factor for the sides is 4 over 10. And we always reduce that. So this is going to be 2/5, right? What is the ratio of the areas? Well, remember, we have to take that ratio 2/5 and we square it. So we get 4 over 25. Well, then we go back and the problem says, well, the area of this smaller pentagon is 27, and they want to know what the area of this bigger pentagon is. So if 4 is to the smaller side, is to the bigger side, then 27 is to the smaller side, and we need to find the bigger side. Well, remember how to do that? We just have to cross multiply. So 4 times x is 4x, and 25 times 27 is 675. So I divide both sides by 4, and 675 divided by 4 is 168.75. So the area of the bigger pentagon then is 168.75, and that would be inches squared. Okay, so look what we did. We took the scale factor. We squared it because we know that the ratio of the areas is the square of the scale factor of the sides. Okay, then we set up a proportion. The small pentagon is to the big pentagon as the small pentagon is to the big pentagon, and then we found our answer. Okay, let's try another one. This one says these triangles are similar. So remember, we have to find that. They have to say they're similar in order to do this. So their areas are given. What's the scale factor? Well, this time they're giving us the areas. So I make a fraction, one area over the other area. I reduce it, so I can cut 50 in half and get 25, cut 98 in half and get 49. And now remember, the scale factor is like the square root of the areas. Because the areas, remember, we had to square the scale factor to get to the areas. So we have to square root the areas to get to the scale factor. Square root of 25 over the square root of 49 is 5/7. That's our ratio. What's the ratio of the perimeters? Remember, that's the same. Good. Okay, let's try one more. So this one says the areas of the two similar octagons are 72 inches squared and 128 inches squared. Find their scale factor and the ratio of the areas. So they're giving us the areas. So 72 over 128. Okay, remember the next thing we want to do is reduce that. So let's see. I'm going to try taking 4 out of both of them. So 72 divided by 4 is 18. And 128 divided by 4 is 32. Ooh, I can reduce more. See, I can cut 18 in half and get 9. And I can cut 13 in half and get 16. Okay, so this is the ratio of the areas. Okay, it asks for the ratio of the areas. So that's our answer, 9/16. How do I find the scale factor? Well, remember, we take the ratio of the areas and we take the square root of both of those. So the square root of 9/16 is 3/4. And that is the ratio of the perimeter. and the sides, or you can call that the scale factor. All right, great work today. We'll see you in class.